So section 3.3 asks us to do some division of polynomials. This is an example of long division. Personally, if I was stuck doing this one, and let me show you the original problem right here, I'd probably write a little bit extra just so I can keep track of my places and stuff like that. So that little bit extra would be some of the terms that are kind of implied but missing. We've got an x to the fourth, an x to the third, an x squared term, but we don't have a term in just x, so I'll put 0x. And then after that is going to come a constant, so plus 0. So I would add all those. Now, the way long division works is a lot of comparison and multiplication, addition, subtraction. In fact, I kind of regard it like this. FM. So the mnemonic is father, mother, sister, brother. But the father step is to figure. You're going to figure out what you're going to multiply by. The mother step is to actually do the multiply. S. What operation starts with an S? Subtract. And then finally bring down whatever figure you're going to work with, or whatever figure you need next. So here's your little acronym, father, mother, sister, brother. And let's see how those apply as we work through some of the problems. So the first thing is to figure out, well, what do I multiply this by to get this? And as far as that step is concerned, you can do this over here. You can do 4x to the fourth divided by 2x squared. That's our figuring out step. And that's going to equal, well, 4 divided by 2 is 2. Subtract the exponents, I'll get x to the second. So that's our kind of figure step right here. So 2x squared, I'm going to put that right above this because those are like terms. 2x squared. That way, when I get down to the constant, I know I'm done. That's kind of a nice feature of lining them up like that. All right, the next thing is to multiply. And as far as the multiply is concerned, you're going to take this times the whole term out in front. Not just the 2x squared, but the 9 as well. So let me put parentheses around this. Let's see. 2x squared times 2x squared, that's going to be 4x to the fourth. And 2x squared times 9 is going to be 18x squared. So father, mother, sister. Sister is next. That's the subtraction step. So I want to subtract both of these. Now, typically what happens when people don't put a parenthesis and take good care on this is they'll subtract the first one, but they'll add the second one. And then you'll be in trouble at some point because you'll be like, well, wait a minute, you know, some number doesn't go into this one and things get all messed up. What I suggest when you do your subtraction is that instead of subtracting, add the opposite. So I change that minus to a plus and change the signs on these terms inside. These first two should always cancel out. So let's see that they do. In this case, yeah, we're lucky. Those cancel each other out. So that's good. Then the brother step, you bring down. Let's see, I'll bring down a negative 2x to the third. And then 20 and 18, or excuse me, 20 minus 18 gives me a 2, like that. So father, mother, sister, brother. Figure out, multiply, subtract, and then we had to bring this one down. Okay. Now we repeat this. So comments or thoughts before I do this process one more time. Actually, 2 more times. All right? So first step, father. We're going to figure out, well, what do we multiply this by to get this? Notice it's always the leading terms. This and this, this and this, and then we'll have one more, this and this. So let me do that down over here. So that's going to be negative 2x cubed divided by 2x squared. What am I going to get this time? Well, the 2's will cancel, right? I'm stuck with a negative. How many x's am I going to have? Just one. Thank you. So just one. So minus x right there. So there and there. Okay. Father, mother. That mother step is to multiply. So it's going to be negative x times all that there. And, what's that going to give me? Well, let's see here. Negative times a positive is going to be negative. Negative 2x cubed minus 9x. Now before I do my subtraction, let me note for you that right after you multiply, these two terms should be identical. This one and this one. They should always match. So that when you subtract, change the signs and add, then they'll cancel each other out. They'll be opposite signs and they cancel each other out. So as with the last one, we'll change the signs and add. So I'll make that a plus, that becomes a plus, and that becomes a plus. Everything's positive. The world's an optimist, so that's good. We'll cross out those. And then I can bring this down. So that's going to be a 2x squared plus 9x. And, all right, looking good here. One last calculation, one last kind of father step, if you will, and that is we're going to take 2x squared divided by 2x squared. Anyone want to work hard and give me that one? You can use your graphing calculator if you need to. I don't know. Looking like the big 1. So let me put that there. Plus 1. And I've got all these kind of color coded so you can kind of see where they're coming from if you wanted to look back. 1 times that is simply going to be 2x squared plus 9. But notice I don't write the 9 underneath the 9x because they're not like terms. If I like at this step, I can bring down a 0 because those are like terms. But what do I got to do now? Father, mother, sister. That would be the subtract step. So, as before, when you're subtracting, and again, put parentheses around this whole thing to remind yourself you got to distribute that negative to all these. You have to change all these signs. That becomes a positive. That becomes a negative. That becomes a negative. And we'll bring down a 9x minus 9. 9x minus 9. Beautiful. This part right here is your remainder. So-called R of x. This part here is your divisor, so-called d of x. This part here is your quotient, q of x. And then last but not least, this polynomial, that's your p of x. All of this in here. I mention that because the problems you're going to face are going to ask you to write your answer in a specific form. So I want you to know all the little working parts. There's your divisor, there's your remainder, there's your quotient, there's your original polynomial. Let's look back at the form of this and see what they're looking for. So they wanted you to write it as p of x divided by d of x equals the quotient plus the remainder divided by the divisor. So the answer that you would have to input into WebAssign would look like this. It'd be your quotient, 2x squared minus x plus 1, plus the remainder, 9x minus 9, over the divisor, 2x squared plus 9. That would be the answer that you put into by the sign. How's that first one look? There's a lot to this stuff. I know it's not fun. It's probably one of the more unfun problems for my Math 1150 students. You guys might find something more unfun than this, but we'll see. Any specific questions someplace that maybe I went a little too fast or can help out? Looking good? All right. You want another one like this, another long division one? Maybe I'll do it a little faster, or? Okay. All right. So let's take a look here. And I think this next one they ask for things in a little different form. This time they want you to write it as P of x equals D of x times Q of x plus R of x. So just mixing things up a little bit. Let me show you why and where they're getting that new form. And it's because they're going to be using that later. So let's take a look here. Now what we just did, let me write that down, P of x. Don't have to copy this, okay? I'm just copying down what we just did a moment ago. Up here. And the idea is that we're going to get a different way to write our polynomial, P of x. I'm going to multiply both sides of this equation to clear out the denominator. So the denominator in here is D of x. If I wanted to just get rid of that, I could multiply both sides by D of x. Now, it might help you to think of this as D of x over 1, so that you do the appropriate cancellation. Here, you're going to get rid of the D of x. So, great. You get P of x. On the right-hand side, when this distributes, I get Q of x times D of x. But when it distributes here, something nice is going to happen. I'm going to get the remainder. Just the remainder. So it's a different way to write it. You've kind of messed with it a little bit. But we're going to see something like this come back at us. Now, as far as the problem itself is concerned, let's take a look back here. It was P of x, so I'll call this example B. P of x equals 4x cubed plus 3x plus 8. And the divisor, D of x, is 2x plus 1. So just copying this stuff down right here. So it's going to be 2x plus 1. Be careful with me here for a second. If you look at this polynomial, is there something that's kind of missing here? Something that you might expect to see?
An x squared.
X squared.
Yeah, there's no x squared term. It's really in your best interest to put it there. It just gets really messy if you try and subtract things and they're not like terms and everything's out of line. So I would strongly suggest you put that there. Now, with our little placeholder there, we're going to do our 4 steps. The first thing is we need to figure out what you're going to multiply by. You need to multiply 2x by something to get 4x cubed. Now, if you're not sure, if you can't just look at that and know, then here's your father step, the figuring out step. It's going to be 4x cubed divided by 2x. And what does that give me? 4 divided by 2, 2x what?
X squared.
2x squared, thank you. So let's write that right over here, 2x squared. And then 2x squared times both of these terms. So you got to distribute that.
4x cubed plus 2x squared.
All right, so 4x cubed plus 2x, right? Looking good there.
2x squared.
2x squared, yeah, 2x squared. How about if I put that here then? And this term never happened. There we go. Here's where we do a little bit of magic. We're going to subtract all of that. And my trick is to change the signs and add. So that'll become a plus, that's a minus, and that's a minus. Now you can add. These first terms cancel themselves out like they're supposed to. If they don't, stop. You've made a mistake. They have to cancel each other out. This gives me a negative 2x squared. Our brother step is to bring down here, so plus a 3x. And cool. Can someone tell me what I'm going to do, what numbers or what expressions I'm going to divide to get the next thing here?
Negative 2 squared divided by 2x.
Perfect. This one, negative 2x squared, divided by this one, 2x. Thank you. And what's that going to give me?
Negative x.
Negative x.
Negative x. I'll put that one up there. All right. So now, negative x times this. So, negative x times 2x plus 1. That gives me negative 2x squared minus x. And again, we want to subtract this. So the trick with subtraction is to change the sign and add. All right. Thank you, Spencer. Plus, plus, and plus. So combine like terms, that cancels out. This gives me a 4x plus 8. And that brings us down to our last comparison, the last figure out step. Let's see, so it'll be 4x divided by 2x gives me 2. Oops. Let's see, I'll continue to do the little color coding thing here. So that's going to be a 2 here. And it's a plus 2. 2 times that gives me 4x plus 2. Change the signs and add. What are you going to get for a remainder?
6.
6. Excellent. Now, let's kind of review all the little pieces of our puzzle. Because it's going to ask us to write it as q of x times d of x plus r of x. So the way this works, it's no different than if I did something like this. 3 goes into 14. Oh, that's going to go 4 times with a remainder of 2, right? And how do you check it? Well, you do this times this is 12 plus the remainder gives you 14. So the same thing's going to happen here. This times this plus the remainder should be this. So our p of x, so 4x cubed plus 3x plus 8 should equal 2x squared minus x plus 2 times 2x plus 1 plus 6. So that's your q of x times d of x plus r of x. Not much of an r of x, it's just a constant. That's okay, you know. But there's your final answer on that one.
I have a question.
Please.
For the last row, you did not change the sign here.
I didn't show it, but I actually did do it in my head. So there'd be a minus there, and when you add down, those cancel. 8 and negative 2 gives me a 6.
Okay.
So, but you're spot on. Yeah, I neglected that. That's my bad. So Appreciate the question. Anything else? All right. Now, this is really a cumbersome process. So, if and when you can, it's nice to take a shortcut on this. So, how does that shortcut work? That shortcut is for synthetic division. And let's see, I think I've got a couple extra handouts here for those of you who happen to be face to face. Venez ici, s'il vous plaît. Here, if I can hand one over to Isatu, that'd be great. Don't know if you really need this for home consumption or not, but this just shows you the correspondence between the long division that we just did and what we're going to do now, which is synthetic division. Synthetic division is really cool. So, let me show you some of the rudiments of synthetic division. So, what we're going to do is we're going to take this term right here, this polynomial, and divide it by x minus 1. Now, synthetic division is only going to work if you divide it by x plus something or x minus something. It's very, very specific. But, given its limitations, it's still really, really cool. Now, if I wanted to divide these, the first thing I need to do is I need to write out all the coefficients. So let me rewrite x cubed minus 3x plus 10 as x cubed plus 0x squared minus 3x plus 10. And now the coefficients are right here. 1, 0, negative 3, and 10. Okay. If I'm dividing by x minus 1, then I get a little change of sign here. Divided by x minus 1 means I'm going to put a plus 1 out in front. Now there's two steps in all these things. You're going to add to go down, and you're going to multiply to go up. I also do something that this handout doesn't really indicate. That's because I stole this from a little thing I saw on the internet. I put a little vertical bar here. Because that little bar here, this last part is your remainder. So, let's see how this one works. A lot of my students feel comforted if I actually put in something below this first number, below the 1, and that's going to always be a 0. So that first number isn't going to change. I've got the number 1 out front. Let's start this process. Add to go down. 1 and 0 gives me 1. Multiply to go up. You're going to multiply by whatever number is out in front. So 1 times 1 gives me 1. And then add to go down again. And we're going to keep on repeating this until we run out of room. 0 and 1 is 1. 1 times 1 is 1. Add to go down gives me a negative 2. 1 times negative 2 comes up here. And finally, 10 and negative 2 give me 8. So that's my remainder. Notice I got the same remainder over here, doing it the long way. This is a polynomial that represents my quotient. That's my constant term. That's the coefficient of x. That's the coefficient of x squared. So it really means x squared plus x minus 2 with a remainder of 8. I'll write it as 8 over x minus 1. Kind of like what we did with the last one. Okay. We're going to come back to that in a minute. Let's do just a pure synthetic division problem. Just to kind of get practice with this. So right here. We'll do this one. So let's copy that down. And let's see, we'll call this example C.
So are we doing a scientific division for that one?
We're gonna find, yeah, we're gonna do synthetic division for this one. So I'm just gonna copy it down first. Plus 2x squared plus 5x plus 5 over x plus 2. So underneath my division sign, I want to write all the coefficients of this polynomial. So let's list those off. That would be a 1, a 2, 5, and another 5. Now leave yourself a little space here for some numbers. And then between the last two numbers, draw a little vertical line. That vertical line is reminding you that that's going to be what here? Your remainder. Nice. Now, if I've got a plus 2 here, that means I got to change the sign. It's going to be a minus 2 out in front. And now, remember, we're going to add to go down, and then multiply to go kind of up and to the right. Now I did suggest that some people are comforted if I put a number here. What number did I put right underneath the 1? 0, well done. So you're going to add to go down, and then multiply, etc. So we'll start it out here. 1 and 0 gives me a 1. Multiply gives me negative 2. And why don't you see if you can't finish the rest? I'll give you a few seconds before I do that. If you're watching this some later date, you can pause the video and try and give yourself a chance to do it. Also, try and figure out what does this mean when you get these numbers. Certainly, one without the other doesn't do much good, so we need to figure out what that means. So let's see. When we add, I think and hope that should be pretty easy. The multiplication, negative 2 times 0, that's still a 0. Add going down, that's 5. Multiply to go up, what comes underneath this 5?
Negative 10.
Negative 10, and add to go down is negative 5. So that's our remainder. This is your constant term, that's the coefficient of x, that's the coefficient of x squared. It always increases from right to left. So my answer here is that's 1x squared plus 0x, which I'll just leave off, all right? This is the 0, plus 5 plus.
So we can't just put plus x.
If you put plus x, then that's really putting in plus 1x. So that would be different than 0x. You can put in 0x if you want, but you can't put an x here in this one, because that would mean there's a 1 there. Plus negative 5 over x plus 2. So this is writing it like we just did. Actually, that's what we did for example A. We wrote it like this. Here's your quotient. So that's your quotient right there. And that, of course, is your remainder, negative 5 over the divisor.
So do we always have to write it like that?
No. Sometimes,
Because on the handouts it just says reminder and put the number.
yeah, well, it depends on what you need. Let me again go back and take a look at this. If I multiplied both sides of this by, say, x plus 2, let's try and visualize what's going to happen. If I multiply both sides by x plus 2, then on the left-hand side, that'll cancel out altogether, right? X plus 2 times this. The denominators are canceled, I'll just be left with this. Here, I'll have x plus 2 times this. So let me write that there. So x squared plus 5 times x plus 2 plus, what's going to happen when these two multiply each other? What's going to be left? Negative 5. Beautiful. So this is a different way, all this right-hand side, to write this polynomial.
Oh, that's what we did.
Yeah, we just did that. But there's something that's really cool about writing it this way. Let me call this p of x right here. So if I wanted to find p of, say, negative 2, well, I claim I don't have to actually do a whole lot of work. So if I did p of negative 2 here, negative 2 squared plus 5, negative 2, I claim that that's really a no-brainer. That's a glance at it and oh, I got it. And the reason for that is right here. What's negative 2 plus 2? 0 times whatever. Does it really matter? It's still 0. So this whole thing disappears, right? And all I'm left with is the negative 5. Wow, cool. Nice. So p of negative 2 would be negative 5. And that's actually a theorem. It's called the remainder theorem. And the importance about that is when the remainder is 0. The remainder is 0, wow, we're in good shape. We've got a different way to factor our polynomial. We can start seeing some of the roots. That's really cool. So to kind of show you again with a different example, and it's kind of the one we just did above, where we did this division. If I were to multiply both sides of this, or multiply everything by x minus 1, x minus 1, x minus 1, this is going to cancel, gives me this. On the right hand side I get this times this plus 8. So in other words, I can rewrite my polynomial like this. Can somebody tell me what p of 1 would equal? If I put in 1, I can put it in here, or I can put it in here. Let's put it in here. What's p of 1 going to equal? 8. Excellent. So dividing by x minus 1 and looking at the remainder is the same thing as evaluating p of 1. That's going to be really handy. It might seem like, oh my gosh, no big deal, but it's actually going to be kind of handy. Now, one of the homework problems is just like that. So let's take kind of a quick look at that. It says find p of 1/4 for p of x equals x cubed minus x plus 2. All right, let's do that. 4. So let me copy that down. So p of x equals x cubed minus x plus 2. And I'm going to try and find p of 1/4, but I'm going to do it synthetically. Now look, there's nothing wrong, and you get the exact same answer if you plug this into your calculator. P of 1/4 would equal 1/4 cubed minus 1/4 plus 2, and we'll find out what it is. But if we're going to do it synthetically, by synthetic division, and this is the only kind of tricky or annoying part, when we're dividing and using synthetic division, you got to change the sign. But if you're evaluating it at some number, you don't have to change the sign. Let me take note for you something important. This is x cubed plus 0x squared minus x plus 2. You have to account for all the coefficients of your polynomial, whether they're there or not. But I'll write the 1/4 out in front. 1, 0, -1, and 2. Now you can use your calculator on these things, that's fine. There's nothing wrong with that. Start out with a big goose egg. 0, zip, nada, zilch, nothing. Underneath the 1, add going down gives me a 1. 1/4 times 1 is 1/4. Add going down. Multiply to go up. 1/4 times 1/4. Multiply the numerators, you get 1. Multiply the denominators, you get 16. And then -1 and 1/16 gives me -15 over 16. 1/4 times -15 over 16 gives me -15 over 64. And then you add going down. 2 plus -15 over 64. Now for convenience, let's rewrite the 2. I want it as something over 64. So I can write it so they have common denominators. So 64 goes into 128 2 times. So my overall answer should be 113 over 64. And if you plugged it into your calculator, you would get this. And right now, it might seem like, hey, no big deal. You know, hey, why do we even bother with that? It would have been done with this 5 minutes ago had we done it with a graphing calculator. Let me show you on the next one. And are we okay with this one, though, before I move on? Doing good there? My homers? Zoomies? Okay. Let's take a look here. So the last one says, show that x cubed minus 3x squared minus 5x plus 15 has a 0 at x equal 3. Find the other two roots exactly. Ooh. Wow, this one's stepping up a little bit. So the last one we'll call example D. This one's example E. All right, so let me copy that down. So x cubed minus 3x squared minus 5x plus 15. So let's suppose that it does have a root at 3. What's that mean? What does it mean to have a root someplace? Let me see if I've got this one programmed in here. Let's see, search for 3.3. Ah, there we go. Let's see. No, that's not the one I want. So let's just put it in here. We'll call it P of x equals x cubed minus 3x squared minus 5x plus 15. And I'll shut this graph off and turn this graph on. Alright, not exactly fitting in the picture like I like, but we can adjust that. So, did I copy this down right? Minus 3x squared plus 15x. Yeah, that looks right. Okay. And you can see that this has a root at 3. So why do we even bother? Well, let's watch and find out. So, if this has a root at 3, then P of 3 should equal what? Excellent. P of 3 should be 0. It crosses the x-axis, root, x-intercept. They're all synonymous. Now, Let's do this with synthetic division. So, let's try it here. 1, -3, -5, -15. And I'll put a 3 out in front. And let's play our little game. Nice big goose egg here. If you want to pause the video and race ahead and see if you can't beat me, that's great. 1, 3, add going down gives me a 0. Multiply 3 times 0 gives me a 0. Add to go down gives me -5. That should be a plus 15 there. 3 times -5 would be -15, and bingo, we get a 0. All right, not exactly a big surprise. We already saw that. But if you go looking on decimals for the other two roots, you're not going to get exact values. You get stuff like this. It's like, well, wait a minute. That's not a nice exact value. All right? Your instructor is going to ask you for exact values. That means things with square roots sometimes. So how does this help us? Well, what polynomial is this? X squared minus 5. This tells me that P of X, let's see, evaluating this is like divided by X minus 3. P of X can be written as X minus 3, because remember 3 is a root, times X squared minus 5. Which looks innocent enough, but this actually helps us a lot, because it's a divide and conquer approach. We know where one of the roots is, right? You can see it. It's right there at 3. But how about the other roots? Eventually, when I'm looking for a root, I want to know where this multiplies to give me a 0. And that means one of these two things has to be 0. I already know where this is 0. X equals 3. Where could this equal 0? Oh. Well, now I don't have to worry about a cubic polynomial anymore. This is just a quadratic polynomial. And now I can move that to the other side and get x. Don't forget the plus or minus, but it's plus or minus a square root of 5. Beautiful. So it's kind of a divide and conquer approach. Once you get one root, you can factor your polynomial, and you don't have to worry about those other factors anymore. You can just concentrate on a smaller problem. So that's what's so cool about synthetic division, and we're going to use that a lot moving forward. Cool. Comments or questions on that one? How's that one looking? Thumbs up? All right. Let's stop things here and take a break.